Hey, good morning, Internet. This morning we're going to talk about OSI layers. And I think I've used that term a few places, and maybe folks ought to understand what it is. So, OSI, Operating System Interface, is a design criteria for computers. They're called OSI layers. There's huge engineering work around how this all works because it's the internals of your computers. Again, operating system interfaces. So all the devices in your computers now have their own OSIs, their own operating systems. And it can be independent of the bus and the main kernel, or it can be a hard tied device that gets its instructions from the CPU kernel. So if you could look out on a computer bus, you would see a whole bunch of addresses out there of end devices. So an end device is a storage area in memory. It's a storage area on a disk. It's the whole disk. It's a disk subsystem. It's an external storage array. It's an external processor that has to be called but can't be done by something inside your computer. So these are all really operating system interface layers. Very complex and intricate. And with the new programming languages, it really is a step away from programming. You don't worry about the underlying operating system. You take for granted the underlying operating system. So when this transition happened over time, the industry needed more addresses for all these devices that are out there on the buses. And the addresses mean bigger words and bigger headers to a message to get it from point A to point B, and they're pretty specific addresses. And who gets to control those addresses? So these are all the engineering conversations that go into that OSI layer architecture, discrete part of engineering. Remember, engineering does more than science does. Engineering applies sciences. So this is what guys sit around and do, is think about the OSI. Inside of OSI is the communications protocol for the internet. This is a discrete, separate, absolutely separate thing. How your computer talks to the internet is an address out there on the internet. And it has its own kernels and subroutines that process the communications flow through the computer systems. So when a message has to go 47 computers away, and some addresses inside of those 47 computers, messaging got extended. So the idea of ports in the internet protocols had to get extended. And the ports have specific uses, but also the addresses now have more specific uses. If you can decode the address, if you can interrogate what's at the end of the address, then you can find out what might or might not be there. So this is the complexity of OSI layers underneath that little computer that you bought from somewhere. And this architecture actually goes into your refrigerator now. It goes into your microwave if your microwave talks to the internet. It's what allows that camera on the wall outside your house to talk to your computer, to talk to the internet, to get you messages. So that OSI layer is all the mechanics of messaging in between devices and how they can flow and what can flow. So if you're listening to the message here, if you're listening to the technical aspects of it, you realize that these device addresses, which are called MAC addresses in the IP world pretty much, machine address codes. That is hard in your computer. Unless you know how to play with it, it's difficult to do, difficult to verify that you've done it. So that MAC address is the computer's home address. And that address is known by where the computer's connected to and blah, blah, blah. But what you can't do is mask that MAC address, because somewhere that has to be buried in the communications layers or re-added if you're trying to do masking. So good luck. Good luck. Just know that what OSI layers are. Know that there's a whole bunch of engineers out there and theoreticists that are working to make the internet work, to make it more secure. But if you're just doing IP masking, if you're doing VPN services, you have a starting address. That address is always there, and that address now includes a whole lot of information. So good luck. There's OSI in under 6 minutes, and it's another piece of how we communicate. Thanks.